Okay, hello, hello. Is it on live? Hopefully. Yeah. Okay, so this is 10 p.m. in Japan time, and the this is Junichiro Horikawa, and this is the weekly tutorial, Houdini tutorial, live that I'm doing weekly. Sorry that last week I couldn't do the live. I was a bit too busy last week, so I'm gonna so sorry for that. So I'm gonna start from today for the next let's say a season. Okay. And this is the 52nd episode for Houdini Algorithmic Live series, tutorial series, and the topic for today is to create a kind of a pattern on a surface, a remapping pattern on a surface by giving you an option to choose the basic element for the pattern, and then show you how you can remap it onto a quad surface to create something like this. So first thing you need to do, you're going to do is to create a basic like element like these shape, and then what I'm going to show you is to how you can remap this geometry onto a given surface like this one, which is divided in quad surface. I'm using a plugin for the Houdini called Quad Remesher, which is a paid plugin. So if you want to use it, you need to pay for it for the license, I think. And together by giving you the quad surface together with the geometry that I'm going to remap, you'll be able to move this geometry onto a surface like this together by doing some morphing effect based on a box shape from a quad surface. Then finally I'm using subdivide to make it smooth surface to create something like these. So it's not just copying, it's not just by using copy to swap node, but I'm using kind of some techniques in order to move the geometry together by morphing it to smoothly connect with the neighbor element to create such a smooth flowed, smooth remapped surface like these. So that's what I'm gonna show you today. Okay. So hopefully you'll be interested in this kind of stuff. It's more of a procedural modeling stuff that I'm gonna show you today. I'm gonna show you several different ways to achieve this effect or achieve this modeling. One way to use the rather easy method, but a bit slower. But other way that I'm gonna show you is a bit more faster way, but it's a bit more complex because I'm using a lot of vex. Okay, so let's do this. And I think it's pretty useful when you want to create like a remapped surface based on I mean from a basic element to create a really complex surface. And I did get the comment saying it might be related to a pufferfish plugin in Grasshopper, which is, I think it's this one. And looking at the result of what it does, it actually, I guess some of the component it could make be related to what I'm going to create, like something like these could be really related to what I'm going to create today, what I'm going to show you today. So yeah, probably might be related. I haven't really used this component myself, so I cannot check the possibilities here, but seems like there's a lot of components here. Okay, hopefully you'll be interested in this kind of stuff. Okay, so let's start by creating a geometry node. And first thing first, I'm going to create a quad surface where I can place the basic element on top of it. So could be anything to try it out. I mean, you could just start with the sphere, which has the quad divisions like these one. It does include the triangles, this one. So maybe what I'm gonna do is to use a from the side effects lab plugin where you can access from the shelf. Where is it? From the shelf, there is a side effects lab. And by installing the side effects lab, you'll be able to access to the node called labs exercise quad remesher, which you will need to get the license in order to use this. I think if you search for the quad remesher for the Houdini, which is this one, you can use this plugin for all sorts of applications. I have bought for all the software license, which is around like $130, which is not that expensive for what it could do. So if you're interested in this kind of if you are getting any benefits using creating a quad remesh stuff, I recommend this a lot. Okay, and by installing this one together with the side effects lab, you'll be able to use this component in order to remesh the input geometry into a quad surface like these. It's pretty useful. Right, so what I'm gonna do is to first prepare a bit complex surface based on maybe a metabole or something. Could be anything. So let's say I'm gonna create a volume first, then I'm gonna use the scatter node to create a bunch of points inside a cloud. Not that much, right? Then I'm going to copy the metabole node to create some blobby shape using copy 2 points. Okay, bit complex, but I guess it's fine. Now I'm going to convert it into a mesh by using a convert node. Now let's increase the U value so that it will be smoothed out. Something like these, a bit more, I guess. Well, there's a bit of problem. I mean, it's a bit too thin, I guess. Let's change the seed. Okay, looks better. Bit of concave here, but that's fine. Now I'm going to then use this quad remesher to make it a quad surface. Looking good. Now I can try with this low number of faces, around 500. Let's see. Okay, so it's around 505. It's fine. Is exoside remesher better than instant mesh? Never try instant mesh. What's that? This one? I don't think so. Instant mesh. Oh, this one? I don't know. I haven't tried this one. There were errors matching the new. I guess I do need the plugins for this one as well. I'm not sure. Or do I need anything else? Not really sure. What does it do? Okay. Okay, I guess I might be missing something in order to use this. Not sure what. Not really sure how I can use this. Okay. Well, I'm just gonna try that later, since I don't know how I can use it at this moment. So I'm just gonna use this one. If the instant mesh node works for you, then that's just fine, I think. Then, because what I just need is those quad meshes, so any way to retrieve it is just fine. Right. Now, next thing I would like to do is to prepare some base element which you want to place on top of those quad primitive face. So what I'm gonna do, I'm just gonna do try with the really simple basic element shape. Just gonna try to with the box shape, and then try to create a extrusion for all 4 faces by setting the individual elements and increase the extrusion distance. Then maybe give some inset as well, like 0.25 or 0.3. Okay, something like this, something like a tripod-like shape or star-like shape or confetti-like shape. Right, now just gonna go with this one for now. Now what I'm gonna do now is I'm gonna do with the easy method, rather easy method, in order to remap the basic element onto a surface. So the method here that I'm gonna use is, first of all, I'm going to create a thickened box based on those quad surface. So let's say this is the bottom surface of the box, and then you also need the top face for the box in order to remap this geometry, which say is inside this bounding box. Okay, so what you're going to do is just remapping this geometry which is in this box onto each of the box which is created from each of those surfaces, each of faces, creating the box. So in order to create a box for each surfaces, what you can do, you can either create an extrusion for each element like this, but the problem here is that as you can see, the neighboring face is not connected if you do like this. So just you can do you can change this to connected components, and then it'll just extrude the surface to the normal direction. But if you try to pick the same surface numbers or primitive numbers from here and here, let's say if you get this primitive, and the number of this primitive is 43, and if you do the extrusion, the same 43 numbers is the actual extruded face. So by having the bottom and top face of this number 43, then you'll be able to get the 8 point, which can be used as a target for the box morphing box remapping. Okay, so to make it, to be able to to explain what I'm going to do, first I've just created the geometry which is inside this bounding box. Then I'm gonna prepare the surface which has this quad surface, and for each surface I'm going to create these box shape. Should be connected like these. Okay, and then what I'm going to do is to remap this geometry to move inside these box. Okay, and that's all I'm going to do. But I cannot just use like copy to sub node, because this doesn't like modify the point position, because as you can see from the previous view, the quad is not always square, but sometimes you have this kind of shape, sometimes you have this kind of shape which is irregular. It's just not perpendicular in terms of the angle. Okay, so in order to be able to remap this geometry which is inside a box onto here, you need to deform this geometry inside a box based on the point deformations for the 8 point of these boxes. So 8 point which construct this box is deforming on each surface. So that's what you need to do. That's what you need to consider, and that's what you need to use as an information to deform the geometry inside the box. Okay, and that's what I'm going to show you how you can do that based on the idea of UV and additional information W to make it three-dimensional. Okay, right, so as I said, I need so let's say this is the bottom surface, and for the top surface I'm just going to use like poly extrude for now as an example. Let's say I'm going to extrude by 0.1. Okay, so I have a height of 0.1 for each surface. Okay, now what I'm going to do next is to make it easy. As an example, let's say I'm going to create a null in between here. I'm going to loop through each of the face using for each primitive. Now I guess some of you might think this is too expensive in order to calculate, because since you have to go from for each faces one by one, and it's gonna make it really slow to calculate for every surfaces or every faces if you have like tons of faces for the base from the base surface. But it is easy to understand, so I'm gonna go with this method first and then show you the other way to make it a bit more faster without using for each loop. Okay, so by using the for each primitive loop, we can access to each primitive faces, and in that case you'll be able to estimate the box shape pretty easily. Since this is the base surface, I'm using the for each primitive. For the bottom face, what I need as an extra information is the top surface from the same primitive number, which is this one. So what I'm going to do is to, first of all, I am going to create a meta import node, and I'm going to use the detail attribute which is inside this node iteration to pick the the corresponding primitive numbers from the top surface, which is this one. Okay, so going to use like a primitive, well, I can just say delete probably, and connect the delete to this primitive, and then change this to primitive and delete non-selected so that I can pick the exact numbers. Now what I want to do now is to access to the detail attribute iteration from this one. So inside here I'm going to use the expression to access the for each metadata and iteration 0. Okay, and as a result you'll be able to get the top face from this one corresponding to these numbers. Okay, now that you have the bottom face and the top face, you have now total 8 points which can be used to create a target box. So what you want to do now is to bring this geometry which is inside this bounding box to this new target box. Okay, the size is different, but that doesn't really matter because you're just going to use the ratio with inside the box in order to remap the geometry. Okay, so let's do that. Now what I'm going to do now is to, first of all, it is safer to sort out the point based on the vertex order, I think, since each primitive has a different point order, I think. So to make it a bit more constant, I'm going to use a sort for the point based on the vertex order so that it will always be like clockwise, I think. Let's check. So 1, 0, 1, 2, 3. Yeah. If you don't use that, probably you might getting the clockwise, but sometimes it might go counterclockwise, or it might go the direction diagonal like 0, 1, 2, 3 or something like that. You don't want that. You always want to have the same order in order to use the technique that I'm going to show you now. So I'm going to need this sort either way, and same for the top part. Okay, now after I have prepared those bottom and top surface, what I'm going to do now is to change the point position of this geometry that I would like to move, which is this one. Okay, so I'm going to connect this into a point wrangle. Then I'm also going to connect the bounding box to the second input, which I'm going to use it as a source box shape. Then I'm going to connect the bottom surface into this third input and the top surface onto the fourth input. Okay, and let's say remap surface. Right, so this is the code that I need to write, and this is the only thing you need to do, only hard thing you need to do for this method. Okay, so if you understand what I'm going to do here, then you just be fine. You can just use it for any of your purposes. Now let me explain what I'm going to write here. Okay, so what I'm going to do is to retrieve the U, V, and W ratio values for the geometry inside the box. Okay, let's say I'm going to remap this kind of maybe not the sphere, but a bit more easy shape, something like, I don't know, a pyramid like shape. Okay. Now, for each of the point which construct this geometry inside a box, I'm going to pick the point position P1, P2, P3, and P4. Okay. And I also want to get the minimum point of the bounding box and the maximum point position of the bounding box. Okay. Now, what I need now is to retrieve the position of each of the point of this geometry as the ratio based on the bounding box. Okay. So let's say this is a U direction. This is the V direction, and for the up, let's say this is W direction. Okay. Now for the P direction, and consider this is the value 0, and this is value 1 for the U direction. Okay. And what you want to do is to calculate the ratio from 0 to 1. Where does this P2 exist? So what you're going to do is to project this onto this line and determine what's the ratio in the U direction between 0 to 1. Let's say it's around 0.4. So in this case, the P2's U is 0.4. Okay, and for the W direction, since the P2 is at the bottom, then and W is also from 0 to 1, so the W for the P2 is 0. Now for the V value, let's say this is 0 and this is 1, and if you project it into this line, it's around, like, let's say 0.2. So P2 V is 0.2. And you do the same things for all the points for this geometry. Okay. And as a result, you'll be able to get the new coordinate for the geometry's point. Okay. And you're gonna use this one in order to get the new point position for the target. Okay. Now let's say you have got this information for U, V, and W. What you want to do now is to retrieve the target shape, which might not be really like a square box or cubic box, but could be shaped like these. Still have 8 points, but the shape is but the length of the edge is a bit different for each one, and maybe the angle is also different. Maybe some of the point is higher, like these. Now what you're going to do is to use this U, V, W coordinates to estimate the position from this box. Okay, and same for these boxes, you create the U, V, and W coordinate for this target box. And by using this value, you'll be able to estimate the point position inside this deformed box. So as a result, you'll be able to, by mapping all those points from this translated coordinate into this one, then you'll be able to create a deformed point position for this pyramid shape. And that's what you're going to do. Hope it makes sense. Right, so easy as I said. Let's first get the bounding box point position for the source, which is this one. Okay, which is connected to the second input here. So let's get the minimum and maximum point position using a get bbox from the second input, min and max. Okay. Now, first thing first, what you want to do is to this, since this is a point, a wrangle, I'm accessing to each of the point. What I would like to do is to get the U, V, and W for each of the point from this original geometry, which you see right here. Okay, so to do that, you can use the range of this bounding box together with the current point positions. So let's say the U value is at the X direction and V direction is at the Z direction, and W is at the Y direction. So for the U value, which is in between, which should be in between 0 to 1, can be remapped from a point X coordinate, which is in between the min X and max X. Okay, so since this is the bounding box size at bounding box point positions, minimum point position for the bounding box and maximum point position for the bounding box, so by getting the X and X value for the both min and max, you'll be able to get the the range of the X. So the point position, the X coordinate for the point position, always within this range. So by using this fit, you'll be able to easily remap in between 0 to 1. And that's all you need in order to remap this point position to a UV W value in between 0 to 1. So do the same for the V and W. V and W. For the Z and Y. Z and Y. Z and Y. Okay. Now that you have got those three values, the next thing you want to do is to use this value in order to estimate the point position inside this target box information. Okay, you have the bottom surface 4 points and the top surface 4 points. So in total you have 8 points. So in order to calculate the point position, what I'm going to do is to first of all get those 8 points first, 8 corner points, which corresponds to the corner points of the bounding box for this from the source. The bounding box was easy to estimate the corner because this is always cubic shape. So you only needed to get the minimum maximum. But for those target box shape, you have an angle shape. Also, you have like different edge lengths. So you have to get all 8 point position for these. So what I'm gonna do is to create 8 functions to retrieve each of the point positions. Okay, now to do that, I'm going to let's say bottom surface point position 1 is point from the third input and then 0. Okay, so do it for 4 times for all the 4 corners on the bottom surface and change the index like this. So this is for the bottom surface points. Now for the top surface, I'm gonna change the name to T-pos, then change the input number to 3. Okay, now you have got 8 points position for the target box corner. Now it's time to estimate the new point position for this geometry, which is going to be remapped inside this target bounding box. Okay. So to do that, oops, what happened? Okay, something happened. What's this? Huh. Interesting. What just happened? Okay, I cannot seem to delete it. Okay, something weird happened. Okay, that should be fine. Now, so in order to estimate the point position on the target position, first thing to do, it's a bit, maybe a bit complex to think how you can do that, but since you have all the 8 points is on the different shape, or you have all the different edges for this target bounding box. So let's say you have like randomish shape, something like this. Okay, now let's say you have u equal to 0.5 and v equal to 0.3 and w equal to 0.8. Okay, and let's say this is the u direction, this is the v direction, and this is the w direction, upward. Okay, so first thing you want to do is to consider what's the point position on these flat surface on a uv direction. And the problem is that the surface for the uv on the bottom and the surface on the uv on the top is not always perpendicular, or not always like having the same normal direction. Okay, sometimes the normal direction of the bottom surface goes here, sometimes the normal direction here goes this way. So you cannot just estimate the point position and end it right there, but you have to estimate the point position on the UV surface on both point position, okay, using these values. Okay, what I mean is that first of all, use these u equal to 0.5 and v equal to 0.3 for the bottom surface. So if the u is 0.5, so it's around this line, which is 0.5 from here and 0.5 from here. And for the v value, which is somewhere around here, so 0.3 from the 0, 0.3 from 0. So the position on the bottom surface with these UV values are somewhere around here. And you do the same operations for this top part. So 0.3 or 30% from the 0 positions and 50% from the 0 positions, so somewhere like here. Okay, now that you have 2 points, it's time that you can use this final W value. What you want to do now is to connect these 2 points as a line and use this value to get the final position. Like if this is say 0.8, then that's like 80% from the 0 position, and the bottom part is 0, so going 80% somewhere around here. And finally you got the resulted point position on the target box by using UVW. Okay, so that's how I estimate the point position on the target box, even if the box is deformed irregularly. Okay, and it works just fine. Now let's try to do that, shall we? Does it make sense to you? hopefully. Right, now let's do from the UV value then. First of all, I'm going to name the target point position, or maybe the target X, or maybe let's say SX. Okay. For the 1, as I'm gonna calculate from the bottom part first. So b pos 1 is going to be the 0 coordinate of the bottom. Okay. Now going to subtract b pos 2 by b pos 1. So let's say this is the u direction, okay, for the target geometry, which could also be like 4 for this one. Either 4 or 2. Either way is fine. If this is the u direction, then b pos 4 minus b pos 1 is going to be the v direction. Okay. Hopefully it makes sense. Now I'm going to multiply by u. Now that's for the one edge. Okay. So you also want to calculate the other edge as well for the x x value. So and actually, yeah. So vector sx2. Well, let's say su2, u1, su2, and then be pos starting from 3. Okay. And nope, actually starting from 4 in this case, and then subtract a b pos 3 minus b pos 4. Okay, and multiply by u. Okay, now that you have a 2 point position on u direction on 2 edges, what you want to do now is to use the v value in order to get the flat the point position on the flat surface for the bottom surface. Okay, so vector suv is starting from the su1 plus a su2 minus su1 multiplied by v. Okay, now that's the maybe it might be better to use b since we're dealing with the bottom surface, right? Okay, I'm gonna rename this to b. Okay, so now I got the bottom surface point position as a buv. Now what you want to do next is to get the top surface UV point position. So I'm going to copy these and rename this to TU1, TU2, TV, and rename this to T, KK, like this. And you got the top point position on the UV direction. Okay. Now, now that you have a 2 point positions, you just want to you want to use this W ratio in order to estimate the point position between VUV and TUV. Okay, so the final final UV W point position is BUV plus TUV minus BUV multiplied by W. That's it. Okay, and you're going to replace the point position with this final UVW value. And let's see if I got these geometry being remapped. And so this is the bottom surface and this is the top surface, and I think the geometry has successfully been remapped from this bounding box geometry onto this target box. Okay, previously the geometry was inside this bounding box, but then by doing this operation, I have just remapped the geometry onto this deformed target bounding box like this. Now what I just need to do is to just do the same operations for every primitive using this for each primitive node, and voila, I have just remapped all those faces like these. And if you want to connect them as one piece, you can go back to this here and remove the side faces. I can just selecting this extruded with the face selecting option and just type delete, but that's not really procedural, so I'm gonna do it in a wrangle way so that it'll be more flexible. So if it's connected to the side, if those edges are touching to the bounding box, if the side faces are touching to this bounding box of this one, then I would like to delete it. For the top and bottom, for the top part and bottom part, I'm not gonna delete it. So let's quickly do that using a wrangle, a primitive wrangle, which most of the people wouldn't do, I guess. So remove side faces. I'm just first going to check the distance of each of the center of this primitive to this bounding box by using XYZ dist. And if the distance is small enough, then I can delete. But in that case, the top and bottom face also might going to be deleted. So I'm going to add another conditions, checking the dot product of the normal with a y direction, and also make it an absolute value, and let's say that the value is less than 0.5. Then you have more chance that the side faces are going to be deleted and the top and bottom faces not going to be deleted. Now remove prim 0, prim num1, right, oops. Okay, so only the side face has been deleted and top and bottom is being preserved. Okay, now I'm going to connect this into the first input right here. Visually it doesn't really change, but you don't have this wall face anymore to connect each element together. Now I can then use fuse so that you can connect all these faces and use the subdivide to make it smoothen out to create as one smooth shape. Okay, easy as that. And you can try to make the extrusion bigger to control the final element size, like these. Okay, so it works pretty well in this case, in this way. And since we're using this for each primitive, it's pretty understandable what's going on here, I think. Although the problem here, I mean, it's not a big problem maybe, but what I think is a bit of problem is that since we're using this for each loop, and this is single threaded, I think it's going to take a little bit of time to calculate if you have tons of faces. Maybe if you use like a compile block, might be easier. It might make it a bit less time to calculate, but if you have like tons of faces, like if you increase the number of faces by setting this into like 3000, now it takes a lot of time to calculate. Oh, let me normalize this. Okay, let me try to count the time by checking the performance. So let's say, what happens if I set the target quad count to 10,000 and see what's happened. Okay, and it took around 12 seconds or 13 seconds in order to calculate the whole stuff. Okay, so that's how much it cost in order to calculate it. Now it might be okay for many cases since it's easier to implement, but in some cases, if you want to have a bit more like performance, if you want to make it a bit more faster, then you might want to do in other way. Okay, so I'm gonna show you the other method, how you can use the same thing but a bit more faster without using this for each loop. But the main stuff, or what I wanted to show, is already done. So if you are like satisfied with, or if you're okay by knowing the easiest way, then I think it's all done here. I have just explained all the stuff that I needed to in order to create the one that I have shown. But so what I'm just going to show you next is just a different way, okay, in order to achieve the same thing. So please be reminded. But if you know the other way, you might also be able to make it a bit more flexible in terms of in order to let's say create a bunch of different geometries for each boxes, something like that. Okay, well, which you could still do in right here as well, though. Just a performance issues. Now let's see, I can have this as the same thing with the quad surface. I'm gonna group this out, and different method I'm gonna show you is first of all, I'm going to create a, let's see, what I'm gonna do first is to create a center points on, or a number of points, same number as this primitive numbers. So currently I have like 505 primitive. Now what I'm gonna do now is to create a same number of points on the 0, 0, 0 coordinate. Okay, which might not make sense at this time, but it's going to be effective later. And like this. So for each primitive, I'm going to create a point at center of the space, set 0, 0, 0. Okay, and also I'm going to set the ID to this point derived from primitive number. So set point attrib 0 ID with the prim num. And actually what I'm going to do is to remove the primitive itself. So remove prim 0 prim num 1. Okay, so I have just created the points on the center, and then I have also deleted all the primitive, and now I'm left with 505 points, which is the same number with the primitive. And each point has its attribute called ID somewhere in here, this one, which is derived from the primitive number. Okay, now what I'm gonna do next is use the copy to points to, since this is the basic element, this one, I'm gonna use the copy to points to copy this geometry, the base geometry, to each of the point right here that I've just created. As a result, I have copied the geometry to the same center positions, and you have like a bunch of primitives has been created on the same positions. But the difference is that each of the primitive has its own different IDs derived from this point. So if you look at the ID, you see that the ID attribute has been copied from these point. Okay, which mean is that the ID, which corresponds to the primitive number, the geometry which is copied on the center, which has this ID, can be corresponded with the face number of the basic surface here. So if the base surface has a number like, let's say 313 here, and that surface corresponds to this basic geometry, which has an ID called 313. Okay, and the reason why I did like this is because in this way I can use the point wrangle as one shot to estimate or to modify the point position for all the geometry in one wrangle without going into the loop with the single thread. But I can use the multi-thread using a single wrangle node, and as a result, it should calculate much faster than using this way. Okay, and all the other calculations that I'm going to do now is pretty much the same as I did here. I just need to prepare some information in a bit different way. Since I have this base surface here, maybe I can bring this back here as well. And this is the top surface as well. Now, what I'm going to do is, first of all, connect the bounding box of the shape. I can just calculate the new bounding box here. Okay, and connect it as second input to this point wrangle. Then for the third and fourth, I can connect this base surface for the bottom and the target top surface, which is right here, just like I did right here. Okay, now I cannot use this sort because we're not looking at each primitive, but instead of using a sort, I'm going to do the similar stuff inside of X. Okay, so I'm going to copy the code that I have written inside for each loop. Okay, and try to reuse as much as possible. Okay, so remap faster. Now, you cannot just use as it is, but you need to change a little bit in order to be able to use it for our purposes. Now, getting the bounding box information using this one is fine because it's connected to the same input number, so that's fine. So UVW, it's fine as well. It's just using the same functions. It's totally fine. Now what we need to change is right here. This only works because we only had one primitive previously, but currently I have connected multiple number of primitives from the third input and the fourth input. Okay, so what you need to do now is to pick the corresponding primitive number based on the ID from this geometry. So this geometry, for each point, I have this ID value, which corresponds to the primitive number. So what I would like to do is to get the primitive, use ID as a primitive number to get the point list from that primitive, and then create something like this. Okay. And you also need to consider the vertex order of the primitive as well. Okay. So considering that, what I'm going to do now is, let me see. What I'm going to do now is, first of all, I am going to retrieve the vertices from each primitive using an ID from the third input and the fourth input. Okay, so int b vts, this is for the bottom, and which is prim vertices from the third input 1012. Okay, and using the ID which corresponds to the primitive number. Okay, and get the top VTS, the top vertices numbers using vertices 3i at ID. Now I've got the vertices numbers, I'm going to convert the vertex number into a point number for 1, 2, 3, 4. Since we're dealing with a quad surface, we should be able to have 4 points. So let's get that. So int bpt1, let's say this is the bottom point 1, is can be retrieved by using a vertex point, but in order to convert the vertex number into a point number, it's on this from the second, or I mean the third input with a VVTS 0, first point, first vertex. Now, oops. Now I'm going to copy this one and paste it 3 times for all the corners. 3, 4, 5, 1, 2, 3, 4, and 1, 2, 3. Okay, so this is for the point number for the bottom surface, and you do the same for the top. So tpt1 t from the fourth input, and from the tvts, and so on. Okay, now that I've got 8 point numbers, I can then use those to replace right here for the bottom point positions and the top point position. Since previously we only had one primitive which contains only 4 points, so we could just say 1, 0, 1, 2, 3, but now we have multiple number of primitives. You don't know what the number is for the point, but you have just retrieved what you need here is, so I'm going to replace it with these point numbers for the top and bottom. Like this. Okay, and as a result, I have successfully remapped the surface just like I did using for each loop. Okay, not much of a change, but just create the exact same stuff. Now let's use the same fuse and subdivide to get the same result. Okay, so this one and this one just gives you the same result. Now what I want to check is the performance, right? So previously it took around 13 seconds in order to create it, in order to create with the 10,000 points or 10,000 faces. So let's try how much it will cost for this one. So I'm going to go to a performance and recode. Now I'm going to change this to 10,000. Let's see what happens. Okay. And going to the, so 10 seconds. Not much of a difference. Maybe I should increase a bit more numbers. Let me try with a bit more high numbers, like 30,000. So first of all, I'm trying with the wrangle way, without using a for each loop. Wait for a moment. Okay. Now it says 26 seconds, 26.6. Okay. So let's refresh it to start from 30. So let's remember it was 26.6. Okay. So going back to the for each loop, and let's try to change this to 30,000. Okay. So first of all, I'm going to clear this up and 30,000. See how much time it will cost. Okay, still waiting. Okay, now it says 34 seconds, so around 8 seconds more than this method. So more faces you have, more time it takes if you use this for each loop method, I think. So if you're dealing with a really high number of faces, then maybe you might want to avoid using this one, but instead make it a bit more efficient by doing this one. Okay, that's one tip. But if the efficiency is not the issue there, then you just don't need to care about it. Okay, now maybe as the last tip, I can show you, oops, I was still going with the 30,000. Let me change the remesh count to something like 1,000. By the way, this remesher plugin can only work with the Python 2, I think. So if you want to use it, I think you need to install the Houdini with the Python 2 version. There's two versions of Houdini, one for using a Python 3 and one using Python 2.7. I try using this one with the Houdini installed with the Python 3 and didn't work, so I think you need to have Houdini Python 2 be available, which might be going to change in the future, I'm not sure. Okay, now has each primitive its own intrinsic UVs between vertices? Wouldn't be possible to use them? Probably you could use that, but it's not always in squarely distributed, I think, if you use the UVs. So sometimes you might get a really weird shape because it's not a quad face. So I'm not sure what's gonna happen using that one. I haven't tried. Maybe you could try. All right. So what I would like to do is, since we're using this copy to point subnode, what's good about this is that it has this piece attributes with the variant, so you can choose the types of geometry to map onto a surface. Okay, so let's try that out with these setup that I've created, so that you can like remap a different types of geometry, not just one single element, but several type of element on a surface using the same rule. Okay, so that's what I would like to try now. Okay, so currently I have just single type here. Now what I could try is change this shape a little bit for the second variety of type to a bit make the shape a little bit interesting. Okay. Let's think what kind of stuff I could do. I could from this, maybe I could let's say, just gonna do manually here. I'm gonna select the top and bottom and use the additional poly extrude. Create something like these. I don't know. Like this. I don't know. But let's try with these. If you just try to use this as a single element, it will look like this. But what I want to do is to use the variant attribute here in order to be able to use this geometry at some part of the face. Okay, maybe using some random value. So what I'm going to do now is to, first of all, in order to use the variant, I need to first check this toggle. Okay, now the next thing I need to do is to set the variant attribute for this geometry and this geometry. So I'm just going to use the attribute create and let's set the name to variant for the point to integer, and this one to be 0 and this one to be 1. Okay, so I have variant 0 and variant 1. Just a small change. Okay, and let's merge these together and connect it to a for each loop. I mean the copy to sub node. Right. now, where does this going? Okay, let's connect. Now, next thing I need to do is to going back to this initial points, and this point should also have the variant attribute. And maybe I can use some randomness in order to set the variant value. Okay, so let's say if rand based on the frame num and some threshold, maybe use some seed value as well. Then I set point attrib 0 variant for PT to be 0, else one. Okay, now let's check. Going to the geometry spreadsheet, so I have variant. Okay, I need to promote those sliders. So let's say seed, say 8.8. So 80% you have 0 and 20% you have 1. So let's see. So 0, 0, 1, 0, and so on. So you have more chance to have 0 and less chance to have 1. Now, going back here and going back here, and you see that some of the geometry has been converted into this shape, which has this top face. I don't know what to say. And then going back here, I like this. Well, it's not that not much of a change, so let me go back this and change this shape a little bit more. Maybe I can increase this one and maybe add some twistness. I don't know. And then make it a bit more taller than this one, like 3. Alright, let's see what happens. Now I start to see some more changes. Okay, became a bit more interesting, I think. Now let's also try to increase the height of the bounding box, the target bounding box, like 1. Alright. Looking good, looking good. 6. And you can control the ratio of the variance. Let's say if you say 0.03, you have more chance to have this taller face. You have, if you go to this one, you have less chance. If it goes like this, there's none. Alright, so that's about it, I think. Hopefully it was interesting for you to know this kind of technique, which could be useful for some purposes. I think it is useful for people who would like to create like a deformable procedural geometry. And the idea can be applied in any like tools, not just on Houdini, but in any computer graphics softwares. Even something like visual programming tools like Grasshopper. Okay, if you have any questions, please shoot. if not, I would like to end here with the things that I did. Okay. Well, so thank you for watching. And we'd love to continue doing this live on weekly basis if I'm not too busy, since last week was deadly busy for me. Wasn't able to do in any date, so but hopefully I'll be able to continue on a weekly basis. Okay, and if you like the video, please press like, and also I am going to upload the file that I've just done onto a GitHub, and then I will paste the link to this video page description page, so that you can download the file to check what I've done in detail. Okay, so thank you for watching, and I am also doing I have also started the Patreon page myself. You can also access it from the video description page. So if you like what I'm doing, if you could support me, that will be also great. I'll be appreciate it a lot. I'm also doing some random live stream which only the Patreon can watch, which I don't do a voiceover, so it's for my hobby. But if you also would like to watch it as an archive, you could support me to watch it as well. Okay, thank you very much, and since I don't see any questions, I would like to end here. Okay, thank you, and hopefully you got something new here as information, and any feedback is always welcome. Okay, thank you very much, and good night.